prior to plunging into the announcement, it's fundamental to handle the meaning of what we're talking about. The Enormous Hadron Collider, LHC, operated by CERN, remains as a great accomplishment in science. Traversing 17 miles, this complicated organization of superconducting magnets isn't only the biggest, but also the most powerful atom smasher in the world. It is an uncommon portrayal of human resourcefulness and intellectual accomplishment. Amazingly, the LHC is strong to such an extent that it has the capacity to reproduce conditions like those during the universe's introduction to the world. However, as we investigate the immensity of the universe, could this machine, which means to open the secrets of existence, unintentionally open us to more dangerous results? Founded in 1954, CERN is one of the world's most lofty scientific research establishments, involving 23 member countries and an enormous community of specialists. It serves as a hub for collaboration and advancement. While the LHC is its lead project, it is just one part of a huge array of particle accelerators and experiments. Consider it a track, not so much for vehicles or ponies, but for subatomic particles racing against one another in a trial of speed, accuracy, and the very nature of space-time itself. At the LHC, protons are accelerated rapidly to nearly the speed of light, replicating the energy levels present at the moment of the Big Bang. The subsequent impacts create temperatures far hotter than the center of the sun. A series of magnets coordinates the protons on their path, while cutting-edge cooling systems maintain the temperature of the magnets at levels lower than space. The crashes are designed to take place at 4 distinct points around the accelerator, where specific detectors, ATLAS, CMS, ALICE, and LHCb, capture data. Each detector serves a unique purpose, offering a different perspective on the repercussions of these crashes. Together, they behave like huge cameras, capturing the fallout, with scientists sifting through the debris to uncover elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that may help us understand the building blocks of our universe. By focusing on the subatomic realm, researchers seek insights into the very nature of the universe. However, each new discovery only brings more questions. The LHC isn't just a tool. It represents humanity's unwavering curiosity and hunger for information. It epitomizes our drive to comprehend the forces that govern existence. Yet, as we push the boundaries of the unknown, we must confront the moral and existential challenges that come with this pursuit. What risks could arise from digging too deeply into the unknown? Could our quest for knowledge open pathways to powers beyond our control? At CERN, where the limits of human comprehension are tested, a troubling realization has emerged, one that has sent shudders down the spines of even the most prepared scientists. Brian Cox, a former CERN scientist and a respected voice in the field of particle physics, recently shared a disruptive statement that has both fascinated and frightened people around the world. According to Cox, the purpose of the LHC is to recreate a scaled-down Big Bang. Yes, a miniature version of the very event that birthed our universe. Cox further explained the significance of this objective, emphasizing the immense potential of the LHC for groundbreaking discoveries, such as revealing the secrets of dark matter, a mysterious substance that makes up a large portion of the universe. This possibility of harnessing the fundamental forces of the universe is undeniably captivating, but it comes with inherent risks. The small Big Bang is not just a theoretical concept, it is a real phenomenon occurring inside the LHC. The collider reproduces extreme heat, pressure, and energy conditions similar to those at the dawn of the universe itself. It's as if we are witnessing the beginning of time itself. But with such colossal power comes enormous responsibility. What if something goes wrong? This is not a new concern. In 1978, Russian physicist Anat Borsky experienced an incident that forever changed the course of his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a malfunction caused his head to accidentally cross the path of a proton beam. The beam, traveling at nearly impossible speed, pierced his skull, entering from the back and exiting through his nose. Despite the intense burst of light, brighter than 1,000 suns, Borsky remained conscious and even walked to seek treatment. The result was both fascinating and disturbing. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of the injury, his mental faculties remained unaffected, and he continued his scientific work. Borsky's experience serves as a stark reminder of the power and potential danger of particle accelerators. The risks associated with a particle smasher like the LHC are not to be taken lightly. There are genuine concerns about unforeseen reactions that could alter the very fabric of existence. Some scientists worry about the possibility of creating a miniature black hole inside the collider. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, destructive forces that lurk at the edges of the universe. The idea that the LHC could create even a small black hole is both awe-inspiring and terrifying. Could such a black hole eventually grow uncontrollably, consuming the Earth from the inside out? CERN scientists have reassured the public that any black hole formed would be incredibly unstable and would disappear almost instantly. Still, the remote chance of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we must first consider the basic operations of an atom smasher. When protons collide at nearly the speed of light, the energy produced is so immense that it can warp the very fabric of space-time itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the object is large enough, it could create a depression so deep that anything nearby would be drawn into it. This simplified analogy provides a glimpse into how the LHC could affect spacetime on a quantum level. At this quantum scale, where the laws of physics appear strange and unpredictable, there is a theory suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC could potentially tap into them, creating a gravitational well that forms a tiny black hole. The likelihood of such an event has drawn the attention of renowned physicists, including the late Stephen Hawking. In his work, Hawking warned of the potential for the Higgs boson to become unstable at very high energies, which could trigger catastrophic outcomes, such as vacuum decay. The esteemed astrophysicist Sir Martin Rees also raised concerns about the LHC's experiments in his book On the Fate of Humanity. He explored the potential dangers of particle accelerators, emphasizing the catastrophic potential outcomes of vacuum instability. He acknowledged that, while the probability of such an event occurring was low, even a small chance warranted careful consideration. Much is at stake, and the margin for error is razor-thin. Scientists at CERN have conducted extensive simulations and investigations. Guarantee the well-being of their investigations. Brian Cox himself has recognized the worries surrounding the LHC, emphasizing that there are rigid security measures in place. These actions incorporate far-reaching audits and conventions to guarantee that the collider projects are conducted with extreme attention to detail. According to Cox, the energies associated with LHC tests are definitely not exactly those that normally happen on the planet, and the possibilities of making a steady black hole are cosmically low. Regardless of whether one were to form, it would be so small and shaky that it would rapidly scatter, delivering an eruption of energy anticipated by Hawking's hypothesis of peddling radiation. Some have estimated that the LHC's tests could open a passage to another universe or aspect. While this thought is largely excused by standard researchers, it has caught the imagination of many, fueling legends and tales. What lies beyond our universe? Might we at any point unexpectedly release powers or substances that we don't have the foggiest idea? The idea of making a way for hell has even been sensationalized in the media, intensifying the uncertainty surrounding these examinations. However, where did this thought come from? And what's the significance in the context of scientific investigation? The concept of parallel aspects isn't a new one. String theory, a main competitor for a unified theory of everything, suggests that there might be more than the 4 aspects we experience, 3 of space and 1 of time. These extra aspects might be hidden from our senses but could, in theory, be accessed under extreme conditions. Imagine the LHC as a key, opening ways to domains that have been concealed since the dawn of mankind. At the point when protons crash into energies never before seen on Earth, they could create waves or disturbances that test these hidden aspects. While this thought remains speculative, it highlights the charm of the unknown. The possibility of discovering additional aspects continues to interest the public, despite the fact that standard researchers remain unconvinced that the LHC will open a gateway to another universe or to hell itself. By the by, the possibility of the LHC being an infinite key, opening ways to new realities, continues to dazzle the imagination of many. So, should we be concerned about the dangers associated with the LHC? It's easy to get swept up in sensational headlines and fears of an infinite catastrophe. However, in reality, scientists at CERN are very much aware of the potential risks. They have taken precautions to guarantee the safety of their tests and constantly monitor and evaluate their work with the utmost diligence. The potential benefits of their research, such as unlocking the secrets of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. While these accomplishments represent a giant leap forward in human knowledge, they come with inherent risks, like all great advances in science. The LHC's tests raise significant ethical questions. Could the creation of exotic particles or the investigation of high-energy conditions trigger unforeseen consequences for our planet or the very fabric of reality itself? These are questions that can't be answered lightly and require careful consideration of the broader implications of scientific progress. In the end, the Large Hadron Collider remains a testament to human ingenuity and curiosity. It has already made significant discoveries in particle physics, shedding light on the mysteries of the universe. But as we venture into these unknown domains, we must remain cautious and mindful of the risks involved. The quest for knowledge is one of humankind's most ambitious undertakings, but it is not without its challenges. The LHC represents the cutting edge of scientific inquiry, where theory meets experimentation and where the very foundations of how we understand the universe are being tested. The journey of discovery is seldom without risk, and the LHC is no exception. It pushes the boundaries of physics, attempting to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must acknowledge the profound ethical and existential questions that arise from manipulating the powers of the universe. The dangers of potentially negative side effects, whether for our planet or for the very fabric of space-time itself, remain a challenge that requires careful reflection. Regardless, the pursuit of knowledge remains one of humankind's most noble endeavors, and the LHC's tests, while hazardous, offer a glimpse into the vast, unknown realms of science awaiting discovery. As we stand on the edge of revelation, the journey to unlock the secrets of the universe requires both ambition and caution. The LHC represents not only the pinnacle of human technological achievement, but also a powerful tool that has the potential to reshape how we understand everything, from the tiniest particles to the most magnificent cosmic phenomena. With each breakthrough, new questions arise, opening new avenues for thought and inquiry. The journey of scientific discovery, though full of uncertainty, holds the promise of revelations that could redefine how we perceive the universe, our place in it, and the very laws that govern it. Perhaps one of the most significant aspects of the LHC's experiments lies in the convergence of theory and reality. For years, physicists have wrestled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to unify these forces under a single framework, a theory of everything. The LHC has been instrumental in providing insights and experimental evidence that brings us closer to this elusive goal. Its work doesn't simply further our understanding of particle physics. It holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas associated with such investigations are important, but the pursuit of knowledge has always carried risks. However, when those risks involve altering the very fabric of space and time, the stakes become even higher. Could an investigation at the LHC unintentionally trigger a phenomenon that we don't yet understand, leading to outcomes that are difficult, if not impossible, to predict? It's a question that scientists and ethicists alike continue to ponder. As we venture into these domains, we must consider the responsibility that comes with wielding such immense power. Yet, despite the potential risks, few would argue that the pursuit of scientific advancement is not worth the risk. The rewards, new technologies, medical breakthroughs, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already changed the scientific landscape, from the identification of the Higgs boson to advances in our understanding of dark matter. These accomplishments have far-reaching implications, not just for physics, but for a wide range of other fields that depend on this foundational knowledge. As we push the boundaries of what is possible, the LHC serves as a reminder that science is never without its uncertainties. No experiment is entirely without risk, and the LHC, as impressive and powerful as it is no exception. Yet, with every opportunity comes the potential for amazing discoveries.